So we have a buoyancy problem here. We have a 7.5 kilogram block of wood that has a density of 570 kilograms per cubic meter. We have a vertically oriented spring with a spring constant of 860 newtons per meter. And we want to find the spring has been compressed by some distance x, right? So that means that the equilibrium is here, the equilibrium position of the spring is here, and the spring has been compressed by some distance x. Okay? Well, let's consider the forces acting on the block of wood here. So, going down our list of forces, we have gravity, mg. There's no normal force here. There's no tension. There's no applied force. There's no friction. There's a spring force. Now, because the spring is compressed, the spring force also points down. If the spring were stretched, then the spring force would point up, which would be the case if this were an air. Let's see, what else? There's no centrifugal force, and then there's buoyancy, which points up. Force buoyancy. Okay, so let's see. If we sum all of the y forces, taking, up to be positive and down to be negative, we get the buoyant force minus gravity minus the spring force is equal to 0, because we're told that this thing is in equilibrium. Well, we're not directly told, but I think we're going to assume that this thing is in equilibrium. Now, the buoyancy force is given as the density of the fluid, and the density of the fluid in this case is water, so that's 1,000 kilograms per cubic meters, times g times the volume of the fluid that is displaced. Okay, mg is the mass of the wood times g, and then minus kx equals 0. Now, the volume of the fluid displaced, because the wood is completely submerged, right? We know that if it's completely submerged, then we get to say that the volume of the object is equal to the volume of the fluid displaced, right? It's 100% submerged. So that means I can replace VF with V wood. Now, the volume of the wood I can actually get, right? I'll do that in just a sec. So the mass of the wood times G minus Kx equals 0. Now, we know that the density of wood is equal to the mass of the wood divided by the volume of the wood. And so if I want to get the volume of the wood, that's equal to the mass divided by the density. Okay, that's 7.5 kilograms divided by 570 kilograms per cubic meter, so that works out to be 0.01316 cubic meters. Okay, so now looking back at my force equation, I know the density of the fluid, I know G, I know the volume of the wood now, that's 0.01316. I know the mass of the wood, I know G, and I know K. I just have to solve for X. So, putting all the values in, I get, let's see, 1,000 times 9.8 times 0.01316 minus 7.5 times 9.8 minus 860x is equal to 0. So 128.95 and I get 55.45 is equal to 860x, and therefore x is equal to 0.064 meters, or 6.4 centimeters if you prefer.